In this video, we're going to focus in on the intercepts for a quadratic function. Our book is referring to this as short run behavior, focusing on intercepts. And since we're looking right now at quadratic functions, that's what we're going to kind of focus on. So what we have are three possibilities for quadratic function. We could have 0 horizontal intercepts, and that would occur if our quadratic function maybe doesn't cross the x-axis, like maybe it hovers above the x-axis. Wow, that's a terrible parabola because it looks all flat. Let me do it a little bit less flat. There we go. That would be an example of no horizontal intercepts. Or if it was facing down, it would just need to be below the x-axis. For one horizontal intercept, that's going to happen if the vertex actually touches the x-axis, something like that. And 2 horizontal intercepts, well, that means that the parabola actually dips below the x-axis, something like this. That would have 2 horizontal intercepts. I want you to notice, by the way, in each and every one of these, the parabola does have a vertical intercept, and it only has one. And it's only ever going to have one vertical intercept. So the horizontal intercepts, that can vary, but the vertical intercept, there's one. It exists like that. All right, so that will always happen. So let's look at an example where we're going to be asked to find the vertical and horizontal intercepts. So stepping through what we know about vertical intercepts, that's when we plug in 0 for x. So I'm going to plug in 0, and that's easy. Working this out, I'm just going to get a -2. So there's the vertical intercept, 0, -2. Okay, horizontal intercept, though, you actually have to set the whole thing, the y value equal to 0, which is f of x in this case. So that means I'm saying 0 equals 3x squared plus 5x minus 2. So to solve this, I need to factor. And if it's been a while for factoring, I can probably post up a video to kind of review that for you. But there we go. Let's factor this thing. So this is going to factor into 3x and x, since that's going to be a 2, and it's a negative. That means that this would probably be a positive and a -1. Okay, there we go. So I factored using what's called trial and error. I just kind of did it in my head, figured out the first terms had to be 3x and x based on the fact that it's got to multiply to 3x squared. The last terms have got to be two things that multiply to -2. And so that's where the -1 and the +2 are coming from. So I just used trial and error to figure that out. There is other methods for factoring. The X method, you might have learned some other version, but I'll post up the X method in case it's been a while and you just don't remember how to do factoring. Okay, now that I factored, I'm going to set those things equal to 0. So 3x minus 1 equals 0 and x plus 2 equals 0. So I'm kind of running out of space. So 3x minus 1 equals 0. That's going to happen. Let me add the 1 to the other side and divide by 3. So when x equals 1/3, and then x plus 2 equals 0, that's when we subtract that -2. Okay, so there's our horizontal intercepts, 1/3, 0, and -2, 0. So 2 of them, and then 1 vertical intercept. So this is an example where it crosses the x-axis twice. All right, let's go ahead and try another one. Vertical, oh, sorry, this is just the horizontal intercepts, just focusing on horizontal intercepts on this one. So we're going to set f of x equal to 0. And in fact, I'm just going to go ahead and kind of write it in the form that we're probably used to, where I put the equal 0 on the right side. Okay, now I happen to know this doesn't factor. I can factor out a 2, which is nice. But this, what's left, x squared plus 4x minus 4, there isn't two numbers that multiply to be -4, but add to be +4. It's impossible. All right. So we're going to have to use a different method. Why don't we try using completing the square? So I'm going to go ahead and go through that process. So first thing I'm going to do is add the C term to the other side. Here, let me switch back to my yellow highlighter. So this is the C term. I'm going to move that to the other side first. And I'm going to divide everything by 2, since the leading coefficient needs to be a 1. So this is going to be x squared plus 2x equals 2. I could have divided by 2 first and then moved. It doesn't really matter. But I keep leaving a space here because that space is representing the thing I'm going to add to both sides. So I'm going to go ahead and put that in there. So what I'm going to add to both sides is I'm going to take the b term down here, that 2. I'm going to take it, divide by 2, and square it. So that's 4. 4 squared is 16. No, sorry. Wow, that's a 1. Just kidding. 2 divided by 2 is 1. And 1 squared is 1. There we go. So I'm going to add 1 to both sides. Sorry, I didn't mean to confuse the hell out of you right there. So on the left side, that's just going to be a 3. On the right side, this is going to factor into a perfect square, and it's going to factor into x plus 1 squared. So if I take the square root of both sides, I'm going to get x plus 1 equals plus or minus radical 3. So solving for x, it's -1 plus or minus radical 3. That's the horizontal intercepts. So the first one is -1 plus radical 3, comma 0. And the second one is -1 minus radical 3, comma 0. Those are the 2 horizontal intercepts. So they're gross, they're ugly decimals, but that's how we could find them. Now, I really don't want to use completing the square. In fact, I mentioned even previously, we're going to want to use the quadratic formula. So let's talk about the quadratic formula. In fact, we're going to actually, for the first time, go through finding the quadratic formula. So you might have seen something like this before. Some intermediate algebra teachers do like to teach this, but we're going to actually step through finding the quadratic formula. And the way you do that is you're going to complete the square. But we're going to complete the square on the standard form. All right, so we need to find the horizontal intercepts. So to do that, we're going to set f of x equal to 0, which means I'm taking this thing, ax squared plus bx plus c, I'm setting it equal to 0. And now I'm going to complete the square. So I'm going to follow the steps I just did in the last example. First thing I'm going to do, move the c term to the other side. And with that extra space, that's going to be when I add that term. Now, since the leading number is not 1, I'm going to divide everything by a. So that becomes x squared. But unfortunately, the other 2 terms are going to be fractions. It's okay. It's going to look horrible for a while, but it'll get better soon. So now I'm going to take the b term, and I'm going to take half of the, now to take half of b over a means I actually have to divide it by 2. Well, when you divide a fraction by 2, I'm going to kind of work this out over here. Oops. When you divide a fraction by 2, it looks like this. But when you divide fractions, you flip and multiply. So this is actually b over a times 2, which is just 2a squared. Okay, and that's going to be b squared over 4a squared. So that's what I'm going to add to both sides. B squared over 4a squared. B squared over 4a squared. Okay, so the left side is going to factor into a perfect square. And it's going to factor into the term I had right before I squared it. See how I just kind of plopped that over there, that b over 2a? That was where I got that from. And on the right side, well, it'd be nice to combine those 2 fractions. So to do that, I'm going to multiply this by 4a. I just realized I switched to green pen and I've been working with red. So I'm sorry, I'm going to change that really quick. Just a small visual cue to me about what we're working on. I want to be consistent. Okay, so we're going to multiply this first term or first fraction by 4a. So that's going to be negative 4ac. I just put the a and c in alphabetical order over squared plus b squared over 4a squared. Okay, so those two now have a common denominator, which means I could put the two numerators together, but they're not like terms. So they just kind of sit there in the numerator. Now, if you remember the quadratic formula, that right side might start to be looking familiar, in particular in the numerator. We typically rewrite it with the b squared first. So I'm going to take a second, put the b squared in the front, because that's going to be more consistent with what we might remember for the quadratic formula. Okay, we finally factored the left side into a perfect square, added the two terms on the right, and now for completing the square, we're going to take the square root of both sides. Left side, that's kind of nice, x b over 2a. Right side, we're going to put a plus or minus in the front, and then I'm going to break up the square root. I'm going to take the square root of the numerator and the square root of the denominator. Now, the square root of the numerator kind of sucks. The square root of the denominator actually works. I can take the square root of 4a squared. It's 2a. So numerator stays. Denominator becomes 2a. And to isolate x, I'm going to bring that b minus 2a over to the other side. And here, I'm going to put it as a negative in front. And the reason is they have a common denominator. So I can actually combine these two together. I don't know why I'm making my minus sign so big, my 2 so large on that exponent. There we go, a little bit cleaner. All right, so now because those two have a common denominator, I can add them together. Here, give myself a little space. And that's going to be negative b plus or minus the square root of b squared minus 4ac all over 2a. And there, my friends, is the quadratic formula. You find the quadratic formula by completing the square. It's a little bit painful, but it's good to know. And that process isn't too complicated if you understand how completing the square works. All right. So let's go ahead and use this to help us in a problem. A ball is thrown upwards from the top of a 40-foot tall building at a speed of 80 feet per second. The ball's height above the ground can be modeled by that equation. What is the maximum height, and when does the ball hit the ground? Okay, I don't need this, but I'm going to draw like kind of a small ghetto picture. Okay, so, and the ball gets thrown off the building, right? Boo, and then it like lands over here. Okay, so maximum height. They want to know where it reaches a high point. Now, this equation that gave us h of t, that's a quadratic, it's a parabola, and it's upside down, which means it has a maximum point. So I can kind of visualize this as a parabola. And this maximum point is going to occur at the vertex. So part A, I need to find the vertex. So h equals negative b over 2 times negative 16. Okay, so 2 times negative 16 is 32, negative 32, and negative 80 divided by negative 32. Let me write that down. Those two negatives are going to become positive, and let's see, 8 goes into both of those. 10 over 4. Oh, 2 goes into both of those, so 5 halves. There we go. There's our h. 5 halves. So let's find k. Now, 5 halves, real quick, let me just comment on that. 5 halves. So what we just found was the t value. So that's when the time that this occurs at 2.5 seconds, basically. That's when that's going to occur, the high point. And then the actual high point is going to be when I plug t in to the original equation. And that's going to tell me the height. So negative 16 times 5 halves squared, 80 times 5 halves plus 40, which is going to come out to 140 feet. So that's the maximum height. So that's the answer to part A. Part B is asking me to find when it hits the ground. They want to know when this thing is going to hit the ground right there. So if I'm thinking of this as a parabola, that means they're asking me to find where it crosses the horizontal axis. So they're asking me to find the horizontal intercepts. Oops, do that in red. Horizontal intercepts. So I'm going to take this equation and it's equal to 0. Oops, I should write the equation down first. So negative 16 t squared plus 80 t plus 40 equals 0. All right, I'm going to use the quadratic formula to do this. So here's what we do. Negative b is negative 80 plus or minus the square root of 80 squared minus 4 times negative 16 times 40. So I'm using A, B, C in the quadratic formula. All over 2 times A, which is negative 16. Okay, so let's simplify this thing. So inside the radical, if you work out 80 squared, that's going to be 6,400. And then if you multiply negative 4 times negative 16, that's going to become a positive, times 40, and then combine that to the 80 squared, that's all going to come out to 8,960 over negative 32. Yuck. Okay. But there's really two answers sitting here. There's two answers. The first answer is the plus case. And the second answer is the minus case. So in the plus case, I'm going to end up, if I plug this into the calculator and get a decimal approximation, that's going to be approximately negative 0.4, oops, yeah, 458. That's what that's going to come out to. And in the minus case, negative 80 minus 8960, square root of 8960 over negative 32, that's going to come out to 5.428. Okay, so this one, this answer here, that doesn't make sense, right? Can't be negative. Time can't be negative. So this answer is absurd, and therefore we throw it out. That means that this is the time where it's going to hit the ground. So to actually figure out where it hits the ground, that isn't what they asked. If you wanted to figure out the height, it should come out to 0 because that's when it's going to literally hit the ground, right? Is when this thing has a height of 0. That's what we just found. But the time is what they asked us for. When does the ball hit the ground? So it hits the ground in 5.428 seconds. I'll put seconds at the end there. And that would be answering that question.